In this video tutorial series, we're going to learn how to use Data Viewer to display, filter, and process eye movement data recorded with iLink systems. Given the enormous range of analysis goals that different eye tracking researchers may have, detailed instructions on using Data Viewer to obtain specific measures from specific tasks will be left to later videos and webinars. The purpose of this series of introductory videos is to provide users with an overview and understanding of the critical features and functionality of Data Viewer, which should provide a solid foundation for understanding how Data Viewer works. Please see our other resources in the SR Research Support Forums for more advanced information for particular lines of research. In this video, we'll discuss the typical Data Viewer workflow and cover the basic steps involved in creating a Data Viewer viewing session and importing iLink data files into that viewing session. Whenever you're working with Data Viewer, you're working from within what's called a viewing session. In typical Data Viewer usage, a viewing session will correspond to a particular experiment and will contain the data from all of the participants in that experiment. So, a viewing session really just consists of the data from a set of eye tracking data files and settings and information like interest area and interest period information that is associated with those files. Whenever you click File, New, File, Save, or File, Open, you're dealing with viewing session files, and the extension of these files is EVS. The workflow when using Data Viewer typically involves the following steps. We'll cover these steps in more detail as we dive into Data Viewer in later videos. For now, the idea is just to become familiar with the file structures and general processes involved in using Data Viewer. First, you'll want to create a new viewing session. Whenever you launch Data Viewer, it will automatically create a new viewing session. But you can also do so at any time by clicking File, New. Then, the idea is to import the eye tracking data from all the participants that were part of your experiment, and that will be part of the analysis in this viewing session. You can do so by clicking File, Import Data, Multiple iLink Data Files. Then, you can simply locate the experimental folder that contains your EDF files. Data Viewer will automatically find the EDF files in all the subfolders of the folder you choose, so you'll usually just want to point to your overall experimental folder. If you program the experiment using Experiment Builder, then you can point to the deployed project folder. Before we go ahead and import some eye movement data, it's important to understand a key feature of how Data Viewer and EDF files work. iLink data files, or EDF files, are binary encoded and cannot be edited or altered in any way. What this means is that when you import your data into Data Viewer, you are reading in this binary data. Any operations you perform in Data Viewer are done to the loaded data stored in Data Viewer. The EDF files themselves remain unaltered, so the EDF files can always be thought of as containing the data as it was when originally collected. It's also important to note that EDF files contain only eye movement data, event markers, such as those which flag saccade and fixation onset and offset, and messages. They do not contain things such as the actual images or videos that were shown during the trial or predefined interest areas. Instead, they contain special messages which are pointers or paths to where this information is stored, which is typically elsewhere in the project folder. This means that if you move your EDF files from their original location and then import them into Data Viewer, it is highly likely that these links will become broken and you will only see gaze data over a black background when you import the files. So, if you need to do your analysis on a different computer than the one that was used to collect the data, make sure to move the entire experimental folder and not just the EDF files. Once you've selected the files that you'd like to import, you can click the Import button. After you've imported all of your EDF files, you'll probably want to save the viewing session, which will save all of this imported data. Please also note, When you save a viewing session, Data Viewer doesn't just save one EVS file. It also saves other files and folders that will be related to that EVS file. If you ever need to move your viewing session to another computer, you can use Data Viewer's built-in package command, which you can find under the File menu. This will pack the EVS file and all of its associated files and folders into one DVZ file. You can then move this one file to the new computer that also has Data Viewer on it, and then double-click that file to automatically launch Data Viewer and unpack it. You can also access the unpack command via the File menu if Data Viewer is already running. After unpacking the viewing session, you'll have a complete copy of the viewing session from the original computer. Once you've got your data imported, you're ready to start the analysis. We'll cover these steps in more detail in later videos, but it's worth knowing the general procedure, and we can use this discussion of the general procedure to also introduce the Data Viewer interface. So next, you'll want to set what's called an interest period in Data Viewer. An interest period allows you to focus in on a specific time window of the trials in your viewing session, and is something you would want to do for essentially any analysis. For example, if each trial involved a picture followed by a question, you can set an interest period to restrict the analysis to the period of the trial when the picture was being presented. Even if each trial just showed a single image, there will be some samples at the beginning and ending of each recording that were collected when the image was not on the screen. For a truly accurate analysis, an interest period needs to be set so that these samples can be excluded. You can access the Interest Period Manager by clicking the drop-down arrow next to where you see Full Trial Period and then clicking Edit. This will allow you to bring up the Interest Period Manager so that you can set the interest periods you need for your analysis. Once you've set your interest period, if you programmed your experiment using Experiment Builder, or if you programmed your experiment in another way and you sent the proper information via your experimental script, you'll then typically be able to see the stimuli that the participants saw during that period of the trial in both the spatial overlay and trial animation playback views of the trial view window. The panel on the left side of the Data Viewer interface is called the Inspector. If you want to change any of the preferences of the viewing session, including some filtering options, then you can modify the settings under the Preferences tab of the Inspector. And you can use the Inspector's Data tab to navigate through the trials of the viewing session. When you select a trial, you'll see its data in the Trial View window. You can use the visibility buttons at the top of the interface to toggle whether different components of the data are visible in the Trial View window. Visible events will also appear in the middle panel of the Inspector, and you can select an event to see details about it in the bottom panel. The Trial View window in general has three main viewing options, and you can switch between which view is being currently displayed in the Trial View window using the buttons at the top left of the Trial View. From each of these views, you can save the data visualizations that are included with Data Viewer as images and videos to help you with presenting your data in papers, talks, and conference presentations. You can also add any interest areas that weren't already programmed into your experiment or edit existing interest areas to fit your research questions. Finally, you can export summaries of the data via the many different output report options that Data Viewer can create. These reports can easily be opened in any statistical analysis package like R, MATLAB, Excel, SPSS, and others. The ability to output these data reports is perhaps the most important function of Data Viewer, and we'll discuss these reports in more detail in later videos.